The water in that glass was a river a few days ago, or rain that soaked into the ground years before you were born. And between there and here, it was cleaned in stages you will never see and pushed to your tap by something as simple as gravity. You turn a handle and it just appears, clear, cold, endless. The most ordinary thing in the house, but that glass is the very end of one of the largest machines ever built, running quietly under your city every second of every day. It has a beginning far from your kitchen, and it did not get to you by accident. So let's follow it. Backwards. From the tap in front of you, all the way out to the reservoir or the aquifer it came from, and then forward again, step by step on the map. By the end, you will never fill a glass the same way. Start with a simple question. Where does your water actually begin? It comes from one of two places. Some cities pull it from the surface, from rivers, lakes, and reservoirs, the big open water you can see. Others pull it from underground, from aquifers, layers of rock and sand that hold water like a sponge, tapped by wells that reach down into the earth. Either way, it starts as a watershed. Rain and snow fall across a wide stretch of land, run downhill, and collect. On the surface, that water gathers behind a dam into a reservoir, a vast patient store held in reserve for the dry months. Underground, it seeps slowly down over years, filtering through soil until it settles into the aquifer far below. Big cities usually lean on surface water because a single reservoir can hold enough for millions of people. Smaller towns often lean on groundwater, which tends to be cleaner to begin with, because the earth has already done some of the filtering. This is the source, miles from your home, often outside the city entirely, sitting in the open air or deep in the rock. Right now, more of it is on its way to you than you could ever drink. But raw water straight from a river or a well is not something you would want to drink. It carries silt, leaves, tiny organisms, and whatever the land washed into it. Before it can reach you, it has to be cleaned, and that means it has to be moved. At the source sits an intake, a structure that draws the raw water in through screens that catch fish, sticks, and the largest debris. From there, huge pumps or a simple downhill slope carry the water along raw water pipelines toward the place where the real work happens. The treatment plant. This is the heart of the whole system, a cluster of tanks and basins, usually quiet from the outside, where cloudy, untreated water goes in one end and safe drinking water comes out the other. Everything the water has picked up on its long journey through the landscape is about to be stripped away. Inside the plant, the water moves through a sequence of stages, each one doing a specific job. This is where a murky river becomes something clear enough to drink. First comes coagulation. The plant adds a small dose of a coagulant, often a compound called alum, and mixes it in. The chemistry pulls all the tiny suspended particles, the dirt and organic matter far too small to catch in a screen, and makes them clump together. As the water moves on and stirs more gently, those clumps grow into larger, heavier flakes. Engineers call this flock. Then comes sedimentation. The water flows into large, calm, settling basins and slows almost to a stop. With nothing to keep them suspended, the heavy flakes of flock drift down and settle to the bottom, taking most of the cloudiness with them. What was murky is already starting to look clear. Next is filtration. The water passes down through beds of sand, gravel, and sometimes charcoal. These layers catch the fine particles that were still too small to settle out, polishing the water clean. It is the same thing the earth does to groundwater, sped up and packed into a single tank, and finally disinfection. Even clear water can carry microbes you cannot see, so the plant adds a disinfectant, usually chlorine, to kill off anything left alive, and to keep protecting the water on its long trip to your tap. Some plants use ultraviolet light or ozone instead, or as well. Out the other end comes water that is safe to drink. In many countries, this water is checked constantly against strict standards. In the United States, the Environmental Protection Agency sets limits on around 90 different contaminants that public systems have to meet, again and again, every single day. Now the water's clean, but being clean is not enough. It has to arrive at your tap with pressure, so it climbs to an upstairs bathroom, sprays from a shower, and pushes through a hose. And the way most cities create that pressure is beautifully simple. Height. From the plant, the treated water is pumped into storage, and some of that storage sits up high in the elevated tanks and water towers you have seen on the skyline your whole life without thinking about why they are up there. The reason is gravity. A tall column of water pushes down with real force. Put a tank high on a tower or on a hill, fill it with treated water, and every home below it is fed by that weight, steadily, without a pump running for each house. The higher the water sits, the more pressure it delivers. That is also why the system stays so reliable. The towers act as a buffer. When everyone showers at 7 in the morning and demand spikes, the tank drains a little faster than the pumps refill it. Overnight, when the city's asleep, the pumps quietly top it back up. And if the power fails, there is still a tower full of water, held up in the air, ready to flow down to you on gravity alone. Now the last mile, the invisible stretch that finally reaches you, and the part almost nobody ever pictures. From the towers and pumps, the water enters the distribution network. This is a buried web of pipes running under nearly every street in the city, the largest hidden structure most of us will ever live on top of. In the United States alone, these water mains stretch well over 1 million miles. It starts with the big trunk mains, wide pipes carrying huge volumes across the city. Those branch into smaller distribution mains that run down your street. And from the main under the road, a single narrow service line breaks off and runs into your home, usually passing through a meter that measures every gallon you use. From there, it is just your own plumbing. Up through the walls to the kitchen, to the bathroom, to the one fixture you actually touch. And finally, the last step you see. You lift the handle, a valve opens, and the pressure that has been waiting in the pipe the whole time pushes the water up and out. Everything before this moment, the reservoir, the intake, the 4 stages of cleaning, the tower on the hill, the miles of buried pipe existed to make these few seconds effortless. So here is the full journey, lit end to end. It began as rain across a watershed, gathered into a reservoir or soaked deep into an aquifer. It was drawn in through screens and carried to a treatment plant. There it was clumped, settled, filtered, and disinfected until murky water turned clear and safe. It was pumped up into a tower where gravity gave it pressure. Then it flowed down through miles of buried mains into a single service line and up to your tap. Days of travel, 100 years sometimes waiting in the ground. Miles of pipe, a whole invisible machine running every second just to fill one ordinary glass. That is the pattern behind almost everything you touch. Your electricity, your coffee, the internet, the food in your fridge. Each one is the quiet end of a system that stretches much further than it looks. Next time you fill a glass, remember, you are not just drinking water, you are drinking a system. This is Veyor, where we trace how the modern world actually reaches you. If you want to see the next everyday thing pulled apart on the map, subscribe, and we will follow the next one together.